another fact family. And we're in the thinking of addition, but we want to be subtraction. So I want you to say the biggest number first, subtract.
6 minus 3.
What is it?
6 minus 3.
So our biggest number, 6, is going to go at the top of our triangle. We're minusing 3, and the only thing left over is 3. So you can see that we have the same number at the bottom of our triangle, right? Okay. Now when I call on you next, make sure to say minus and start off with the biggest number.
12 minus 6 equals 6.
12 minus 6 equals 6. So do you guys see how we always want to start off with the biggest amount? And we want to take away one of our multiple numbers, one of our double numbers, and it always gives us the same double number, right? Awesome. Let's just run through the ones that we missed so far. What have we missed for doubles all the way up to 10? We said 6, we said 3.
5 plus 5 equals 10.
That's right. Now tell me it with a subtraction problem.
5 minus 5 equals 10 minus 5 equals
10 minus 5 equals 5. What else haven't we done yet? Anyone else?
10 minus 10 equals 0.
10 minus 10 does equal 0.
Can I supply you every day? Here.
So our add-ins, if we were to change this operation, this sign, it would still be the same, wouldn't it? We're changing the operation to subtraction today. Cooper.
80 minus 40 equals 40.
That's true, but we're just working with smaller numbers today.
10 minus 5 equals
10 minus 5 equals 5. Any other ones? Miss Shadeen?
I'm just wondering about the second triangle. How does that work?
10 minus 0 equals...
What should actually be the big number when you do 0 and 0? You can do 0 and 0. You can play around with that, but what would it be? Who can raise your hand and tell Miss D? What would it be? Natty's got it.
0 minus 0 equals 0.
That's okay.
See, nobody's perfect, are they? I was too busy thinking about all the other numbers. I didn't catch my flaw. Any other examples?
9 minus 5 equals 4.
Well, that's true, but we're only working with doubles today.
Oh.
I think we all get the point, right? We want to start off with that big number, and then we're going to subtract our smaller number, and the two smaller numbers are going to be the same number. Does that make sense? Show me with a chin check. A 4 if you totally understand that, and you could teach someone else. A 3 if you understand for yourself. 2 if you're not sure, and 1 if we need to start fresh. You guys I'm seeing a lot of 3s. That's good. That's good. We're going to have a chance to practice this with animal crackers, and you're going to make your own fact family. But we're only using doubles. Do you have any questions? We'll have to see how well you work with them, right? So I want you guys to go quietly to your table and grab out, I haven't dismissed you yet. Come back, please. You guys will go quietly to your table and grab out a whiteboard. And do you have markers too? Do you have erasers?
Yeah.
Okay. So you will go to your table, grab whiteboard, eraser, and a marker. And sit quietly at your desk, please. Let's see what they don't have. Okay.
It is. It's really nice. Yeah.
Okay, so I'm
And she actually has a full time.
Sit down, Carter. That's you.
Right there, middle school. Easy day for her.
Did you want, I was going to say, did you want that sunshine?
Oh, class.
Oh,
You guys should be transitioning quietly. There's a lot of noise going on.
Happy class.
Happy.
If you do not at this point have your eraser, you may get a tissue. If you do not have a marker, please put your hand in the air. All right, put your hand down. I'll get to you.
Okay, some of you are getting more supplies out, but I want you to just listen quietly. So, we are going to use your dry erase board and the supplies along with that to create a subtraction problem. What is going to be the biggest number? What is going to be first?
You're going to use the biggest number first.
The biggest number. And then the two other numbers are going to be the same numbers because we're working with doubles today. Does that make sense? I'm going to hand out 20 animal crackers. You will get 10 of each color. There's no question if you're getting more of each of the other. You will just get 10 of each color. Now some of them might be broken. So if you have little legs or little ears, put them aside. We won't count those as a whole cracker. Okay? You're just gonna count the majority of a big cracker as one. And I will give you problems on the board. I'll move that up. And what I want you to do is make the total, and then you will show me how to split them up. Okay?
And then Miss D, are they creating their own triangle with that fact family on their whiteboard?
Yes.
Okay, so you'll give them the big number only, and then they have to figure out the rest?
Yep, so
Okay.
I'm going to give you guys the biggest number, and you guys will make a fact family on your board of the triangle and where all the numbers fit, okay? And you can use your animal crackers as manipulatives. You can move them and separate them to try to see what is the double fact family. So, you will not be eating the animal crackers at this point. You will be using them to make your problems.
Second graders, if your mom worries about germs, don't worry. Miss Aubrey cleaned off your desk before we put these down.
I want to do a super slow. My snacks and crackers.
Oh, there you go. Happy class.
Happy, yes.
What I'm noticing is some phenomenal listeners. There are multiple kids who already have triangles down on their board. That's fantastic. You know exactly what's happening.
Okay, we can get started with your triangles. So you should have a triangle on your board. Now, if you figure out the problem very quickly, you can practice other fact family.
Can they even do ones that aren't doubles if they are really getting this?
Yep, if you really understand, you can do one that are not just doubles. You can do 11, you can do double digit numbers too. But right now we're just going to focus on the doubles. Okay, so the first one is 18. I'm giving you the big number, so you should be putting 18 where?
On the top.
On the top. And now as you get your animal crackers, you can separate, count out 18, and then separate them into 2 piles to see. Yep, so you should have 18 at the top, at the tip of your triangle. That's okay. So you should have 18. You have to wait till you have all your animal crackers, and then you can divide them out.
So Misty, what they can do is when they get all of theirs up, so they make a row of 18, they can make 2 equal groups until all their animal crackers are gone.
Exactly.
Okay, so 1 here, 1 here, 1 here.
Okay, so you want to count out 18 total. Count out 18. So you want to count out 18 and put them all in a row. And you should have 20.
How many do you have right here?
But we only need 18 for this problem.
Nope, how many do you have here? Okay, put 18 on the top of your desk. Okay, so 9 is a little number. And then count how many you have here. Good. Okay, Bryce, so you're going to put 18. So big number 18. So that's the number we're starting with. 2, 4, 6. How many do you have here? 14,
Okay.
18, right? Now, here's your big
So
number.
how much?
We want to put your big number.
Blank plus blank equals what?
We're doubles. So,
You told me you have how much in this pile?
so you have 18 here.
You told me 9. And how many in this pile? So where do the 9s go?
I put these into 2 equal groups.
Good job.
Why'd you minus 4?
Okay, do you have,
That's what it
did you count out 18? Okay, and then did you separate them?
Yeah, but this is 18.
Where's your pile of 18?
Oh. So, how many do we need? A little number 9.
If 10 plus 10 equals 20.
Oh no. Happy class.
Happy, yes.
You have to hurt your animals. Don't let them fall to the ground. You have 3. Cooper. How many would you have?
Happy class.
Happy, yes.
All eyes on me, please. All eyes. So, some people are counting out their 18 crackers because that's what our number is. And then they're taking them and putting them in 2 piles. One goes here, one goes there. One goes here, one goes there. Until they're separated evenly. Equal on each side. Okay, so if anyone's confused, that's a good strategy to have. Count out 18 and then separate them and make 2 piles evenly. Does that make sense?
Yes.
Who can tell me why in this way we're putting 2 separate piles that are equal? Because we wouldn't always do this when we're trying to figure out a missing addend. How come we get 2 equal piles? What are we working with right now, you guys? Natalie?
Double.
Because we're working with doubles, you can do 2 equal piles. If you weren't working with doubles, the piles would not be equal.
Good job. And yours? Okay guys, for those still working on the 18, you can keep going. Otherwise, I'm going to give you another one.